Okay, here's the next lesson. We are solving equations with rational exponents. So the previous lesson, this is going to piggyback on the previous lesson. Again, we're just working with bases and exponents. Bases, right? Bases and exponents. This is the ideal situation here where we have something like 2 to the power of x plus 5 is equal to 2 to the power of 3x minus 7, right? We want to have the same base. We want to be able to get the same base, right? And once that's pretty much true, or you were able to get that, then we're able to solve and set the expressions and the exponents equal to themselves, equal to each other, and solve it. Yesterday was kind of like part 1. This is part 2, right? This is going to be part 2. It's going to say solve. And now they're going to get a little bit more intense, a little bit more rigorous. Okay, so let's jump in here. Number 1, let's solve this one. 216m is equal to 6 to the power of 2. Now, we don't want to change anything, any numbers, even if they're to a power. We don't want to change them and put 36 here. We want to try to get a base, the lowest base, and an exponent. Right? The lowest base and an exponent. And right now I have a base of 6. And I want these to have the same base. So usually and hopefully the lower or the smaller of the bases, you look at that and you see if you can convert this one to also with the same base, in this case a base 6, but then you're also going to have something else up here in the exponent. So we got to be mindful of this and careful with that. So is 216? Can 216 be written with the base of 6? Well, let's see. 6 to the power of 1 is 6. 6 to the power of 2 is 36. 6 to the power of 3 is 216. There it is. So 216, I'm going to write as 6 to the power of 3, but you still got this m right here. See, that it has another power up there. And here's something we got to remember from Algebra 1 and Algebra 2. So I was able to write this with a base of 6. I'm not going to change this to a 36. I want to leave it at 6 squared. We want to keep the base at 6. We want the bases to match. And then now here when you have a power or an exponent raised to another power or raised to another exponents, those multiply. So 3 times m, that'll be 6 to the power of 3m. They multiply. Is equal to, and then 6 to the power of 2. Okay, so this is the scenario that we want. Once we get the bases to match, then what? Now we just do the solving part here for the exponents. Whatever's left here, whatever expression here and here, you set them equal to each other. It'll be 3m is equal to 2. That'll be m is what? Divide by 3, divide by 3. M is 2 over 3. Okay, that's number 1. So it's going to be a little bit more work, a little bit more. You'll see, you'll have a power and it's maybe raised to another power. You're going to have to multiply. Okay, let's look at another one. Number 2. What about 625 to the power of negative 2r is equal to 5 squared. Again, don't just leave this with a base of 5. Don't change it to 5 squared is 25. Leave it. Maybe 5 is the base that we want. Well, is 625 a number that can be written as a base of 5? The answer is yes. 5 to the power of 1 is 5. 5 to the power of 2 is 25. 5 to the power of 3 is 125. 5 to the power of 4 is 625. 5 to the power of 4 is 625. So we're going to change this to 5 to the power of 4. But notice we have it already to a power. So we got to put the parentheses and know that that power is, this 625 is 5 to the 4, and it's still raised to this negative 2r right here. And this on the right side, well, this stays the same. And what happens here when you have a power raised to another power? Those multiply. So that'll be 5 to the power of negative 8r is equal to 5 to the power of 2. 4 times negative 2r is negative 8r. Okay? Then, once these bases are the same, well, we got the 5 equal to the 5. That's what we want to do. Now we just solve for the equation left up here. So that'll be negative 8r is equal to positive 2. We're solving for r, so we divide by negative 8. That'll leave us with r is equal to 2 over negative 8. Well, the negative, we never leave it in the bottom. We're going to move it to the middle or the top, and we can reduce that. So you're going to get r is equal to negative 1/4. Okay, now let's pick it up some more. Number 3. That is 16 to the power of 3x plus 1 is equal to 64. Now here, let's see, what is going to happen here? Well, here we got the situation where 16 cannot be, or 64 cannot be written with a base of 16. I got 16 to the power of 1 is 16. 16 to the power of 2 is like, gosh, I don't know what it is. Let me check. I think it's 256. I think it's 256 or it's 196. I don't know. Let's see. 16 squared. 16 times another 16 is 256. You see, I'm not going to get a 64. So what do you do here when this number cannot be written to this base? Well, what's going to happen now is if you can't write the bigger number as a base of the smaller number, then this is where you have to find a number smaller than both of these that can be a base, for both. And I'm going to tell you what it is. It's going to be 4. See, 4 can be, 16 can be 4 squared, right? Let's write the powers of 4. The powers of 4 to the power of 1 is 4. 4 to the power of 2 is 16, right? Here's my 16 right there. And 4 to the power of 3 is 64. See, I can write this as a base 4 and this as a base 4. So here, 16 was not the base that we're going to use. We're going to have to go with 4. So this one, first one, 16 can be 4 to the power of 3. But keep in mind, we still have this 3x plus 1 up here. And that's going to equal to, and now this 64 can be written as what? 4 to the power of 3 is 64. Oh, that doesn't have an exponent. So just leave it 4 to the power of 3. Oh, I didn't need the parentheses. And here's where there's something new that's going to happen. Watch out right here, because I have an expression. I got 3 times 3x plus 1. So here you're going to have 4 to the power of 3 times, so we got this 3 right here, and you have to multiply 3 times. Now we got an expression, so it's 3 times 3x plus 1. Don't just multiply the 3 to this one. It has to actually what? Distribute. So you got to watch out right there. Equal to, well, this is just 4 to the 3. That's what's new right there. Yeah. 4 to the power of 3 times 3x plus 1. So you got to use distributive property and distribute. So you're going to have 4 to the power of 9x plus 3 times 1, 3 is equal to, and then 4 to the power of 3. Okay, there it is. So I was able to get this to a base of 4. And then now you can solve, and we put these exponents equal to each other and solve. That'll be 9x plus 3 equals 3. Oh, we're going to get 0? Looks like it. Well, looks like 0 is it. Is that right? Did I do this right? 9x plus 3 equals 3. 0 doesn't work, does it? No. Oh, I copied something wrong. Oh my God, what a mistake. I copied something wrong. This should be, I don't know why I put 4 cubed. I'm sure some of you caught it. I put 16 4 cubed. Sorry, I was thinking of this one. 16 is 4 squared. I knew there was something wrong. Sorry, let's fix that. 16 is 4 squared. You see, even I make mistakes, and that's fine. But I caught it. I knew this answer didn't make sense. Okay, that's fine. So that should, 16 is 4 squared. I don't know why I put 4 to the power of 3. And then this would be 2 times a 3x plus 1. And 2 times 3x plus 1 is 6x plus 2. Right? 2 times 3 is 6x plus 2 times 1 is 2. 6x plus 2 is equal to 3. Oh, this should be 6x plus 2. I made a big mess, huh? 6x plus 2 equal to 3. 6x plus 2 equal to 3. That would be, well, let me just do it over here. 6x plus 2 equals 3. That would be 6x equals 1. Okay, I'm going to get 1/6. Yeah, that's it. Well, I did mess up, huh? But see, I was able to check it and fix it. Okay, let's do another one because these are going to get tricky like that, right? All right, how about number 4? Now they're going to get a little bit more challenging. We've seen this scenario before. 1 over 25 to the power of negative 3n is equal to 625. Well, let's see if I can do this. I'm going to tell you, I already know, when I hear 25, I know the base is 5. I know the base is 5, and some of you just have to learn your powers. So I know 5 to the power of 1 is 5. 5 to the power of 2 is 25, which I know I'm going to use for this one. 5 to the power of 3 is 125. And then 5 to the power of 4. And here's my 625, right? So I'm going to change the 25 to 5 squared. And I'm going to change my 625 to 5 to the power of 4. Okay, so that's what I'm going to do. You have to change this to a base of 5 and change that to a base of 5, yeah? So that'll be 1 over 5 squared, right? That's the same as 1 over 25. And don't forget, you still got the negative 3n power there, is equal to, and 625 is 5 to the power of 4. See, my base I know is a 5, sorry. A 5 is my base here, and a 5 is my base here. And we saw this in the previous worksheet. We don't want a fraction. We're going to take this and move it up. And what happens? Well, that's going to turn into 5 to the power of what? If this is a positive 2 and I move it up, it's a negative 2. And don't forget, you still got this negative 3n right there. And then remember, when you have a power to a power, you multiply those. Multiply. So I'm left with 5 to the power of 6n is equal to 5 to the power of what? 4. And here we go. That was the whole thing, to get the bases to be the same. Once I get the bases to be the same, you solve the equation left up here where the exponents are. That's going to be 6n is equal to 4. That's going to be n is equal to 4 over 6. When you reduce that, it's going to be 2 over 3. Okay, one more like that. That one was pretty good, huh? One more like that. Let's see. Okay, number 5. Okay, let's go with 1 over 4 to the power of negative 3a, right? They'll change the variable, that's not a big deal, is equal to 64 to the power of 2a plus 3. Well, I already know 4 is going to be the base. I know I can write that as a power of 4. And that's going to be 1 to the 1 over 4. But remember, 4 right now is to the power of 1. You got to recognize that. 4 is to the 4 to the power of 1. It still has this negative 3a is equal to. That 64 is 4 to the power of what? 3, right? 64 is 4 to the power of 3. And you still have the 2a plus 3. So something's happening on this side and something kind of different is happening on this side. Well, let me do the easy part first. I know this is going to be 4, and then these have to multiply, so that's going to be 3 times 2a plus 3. So I'm just going to set it up, not going to multiply it, but I know this is going to have to distribute, which I will do on the next step. That's what's going to happen to this side. But what's going to happen to this? I don't want a fraction. Remember, when you have a fraction like that, this is going to move up. And that's really going to be what? 4 to the power of what? Negative 1. You got 4 to the power of negative 1, but you also have it to the power of negative 3a. What happens to those? Those multiply, right? So what is that going to give you? 4 to the power of positive 3a is equal to 4 to the power, and now I'm going to distribute this. This is going to be 6a. 3 times 2a is 6a, and 3 times 3 is 9. And now we got it to this place where we want to get, we have the same base, and now we solve the expressions up here and set these exponents equal to each other. So that'll be 3a is equal to 6a plus 9. And I'm going to get negative 3a is equal to 9, right? When I move this positive 6a over there, it's going to be negative 3a, right? Negative 6 plus 3 is negative 3a, and you're going to get the answer. A is equal to, I mean, there's different ways to solve it, but you're going to get a is equal to negative 3. Okay, there it is. Good luck with this assignment.